So what is 4 to the x equal 20, and what does that kind of have to do with, well, really, this final topic this week? I want you to notice something about that equation. I mean, you can jot it down if you want. You can just kind of look at it, but it's got x in kind of a new place. It really is a new place. Now, it's not like you don't know what an exponent is, but we've never actually had x in the exponent. And let me just say that again. When x is in the exponent, that's a new place for us. Do you realize, though, that there is an exponent that you could put on 4 to get 20? Now, I'm pretty sure that it's between an exponent of 2 and an exponent of 3. That's a pretty big space, though, so maybe it's like halfway in between. Maybe it's like 2.5. Well, that's still a little bit too big, so maybe it's like 2.4. Maybe it's 2.3. Maybe it's 2.2. Maybe, geez, I should have just started at 2. Whoops, I just typed the wrong number, 2.1. Now, I'm doing a little bit of guessing and checking, but I'm hoping you're noticing that I'm kind of getting close to 20. And so maybe it's 2.15. Maybe it's 2.16. Maybe, do you agree that there probably is some exponent that's going to get me 20? I'm getting a little closer. Maybe it's 2.161. And I kind of know what the answer is, so I'm going to stop right there to 3 decimal places. It looks like that I've gotten pretty close. Now, most of the time in math, we don't use a guess and check method to come up with answers. But my point here is that there is an answer. And something you're going to learn today is going to help you to get that mathematically. So there is an exponent that you can put on 4 to get 20. And again, it's about 2.161, at least about, to 3 decimal places. So what is this L word? What is this basically logarithms? What are logarithms? And why do we need them? It's a pretty loaded question here this morning, but I think I'm going to be able to give you a good answer to both of those. We'll figure out what they are and even why we need them. Now, once again, this is one of those concepts that you should have seen in Algebra 2. Maybe you'll say, yes, I have seen some of this. Maybe you'll say, no, you have not. But as I always say, it doesn't really matter to me. Let's just learn it this year so that you have a good idea of what are logarithms and why do we need them. Let me back up a little bit to something you are familiar with, and you probably do want to jot this down. That is a comparison with exponential form, something you are familiar with, exponential form. And then, as you're going to see me do, let me give myself a little different space here. Exponential form, we'll just put it this way. And then something that we're going to call logarithmic form. So exponential form, something that you are familiar with, and I'm going to help you see how that relates to something called logarithmic form, something we're going to try to get you familiar with. Now, if I write down on the board 3 squared equals 9, I don't think any people are going to blink at that. Everybody knows that 3 squared equals 9. That's an exponential statement. We can actually make that same statement, that is a base of 3, an exponent of 2, equaling 9. We can make that same statement using something called a logarithm. Now, first of all, we abbreviate it, and you'll see that the numbers end up in a different place. Now, just so you know, that 3 is like a base. So you would say the log base 3. If you were going to speak this to somebody, you'd say the log base 3 of 9. And it turns out that that's equal to 2. Now, maybe that doesn't make a whole lot of sense to you, at least early on here, but I just want you to realize that that's actually the same statement that we made right here. So notice that 3 is the base. Notice that 2 is the exponent, and it's the value that ends up in this place. So we call it log base 3 of 9 equaling 2. Let's do another exponent. Now here's a negative exponent, just trying to keep you honest here on a Monday morning. But I hope you would make that positive, so you would do a little flip, and let's just do it. Let's do 2 to the 5th to be 32. Now, to write this as a logarithm, maybe we can, just from the previous problem, notice that we're just moving numbers in kind of a different place. So try to notice that. The base is 2 right here. The base is 2, so it'll be a log base 2 here. Now, it's the log base 2 of the 1 over 32. But here's the interesting thing that I want you to start to realize. A logarithm is always equal to an exponent. So, of course, there's only one exponent in this problem, and that's what this logarithm has to equal. Logarithms are always equal to exponents. When a student looks at this logarithm, they should actually look right here and say 2 to the negative 5 is equal to 1 over 32. Yes, it's the same thing you're saying here. It's just written in logarithmic form. Let's try to get the idea. If you're starting to say, okay, but why do I need this? Well, hang in there. We're going to go over what is a logarithm, then we'll talk about why we need it. But first of all, 4 to the 1/2, that's just a good problem. I hope that you're thinking that as a root. That's the root of 4. And so that actually makes the number go down to the number 2. Once again, this is an exponent statement. 4 is the base. I can make that same statement doing a log base 4. You would say log base 4. Now it's of 2. And are you catching on a little bit here? Logarithms are equal to exponents. The exponent's 1/2. That's what this log has to equal. Now I'm trying to show you that logarithms can equal like a regular integer. They can equal a negative integer. And here we have a logarithm equaling a fraction. Hey, it's all good because logs are exponents, and exponents can be integers, they can be negative, or they can be fractions. E to the 0. Now, I'm purposely getting the letter E in here. We talked about it a little bit last week, but honestly, E is just a base. So here we have a base to the 0 power. Well, I hope everybody remembers that anything to the 0 power is always equal to 1. We can write this statement using logarithms. Log base E of 1 is equal to 0. Log base E of 1 is equal to 0. Now, I don't know if you saw this coming. It would be possible if you've seen some of this before that you might have an idea, but it's okay if you have not, because this will be the last time you'll see somebody write, at least in here, log base E. Why am I making that yellow now? Well, because log base E is a special log. It's a special log. It's actually called the natural log. Even if you're still a little unsure about what is a log, I want to make sure you realize that this yellow log base E, you'll never see that in that notation. Instead, you'll see ln. Now, ln just stands for the natural log. And basically, it assumes a base E. What does a teacher mean? It assumes a base E. Well, you don't have to write it to know that there would be a base E for this problem. Again, you don't need to write it to know, because we use ln. It stands for natural log. Now, if you're saying, well, what's natural log? It's just a log that has a base E, because remember, E is the natural number. Okay, now a lot has been said in just this little chart, but I want to pause and make sure you realize that a logarithm, by definition, will always be such that if you have b to the x equaling a. So again, b to the x equaling a means that b is the base. Obviously, x is the exponent, and it's equal to a. That can be written as log base b of a, where the same thing is happening. B is the base. It's equal to the exponent, and it's always the log of the value. So it's the log base b of a. And then we have the same statement written with an e to the x. And you've heard me say this, but I want to present it because it often does help students to kind of just keep straight. Okay, what are you talking about? Well, I'm talking about exponents. Logarithms really are equal to exponents. Okay, now I get it, especially if you've not seen this before, if you're still kind of like not quite sure yet, Mr. Naylor. Don't obviously make too many judgments yet, and certainly don't give up. Let's continue to work out what can we do with logarithms. One of the things at this point that we actually can do is evaluate. Now, evaluate is just kind of a generic term for find the answer. And I'll share that we really don't need a calculator to do this. I actually don't really want you to worry about your calculator. However, soon we will punch some buttons on there. So we're still just kind of thinking. We're thinking about exponents. Now, believe it or not, the log base 6 of 36 is a number. Sometimes I find that kids just don't realize that a log is actually equal to a number. And all you got to be doing in your head is just kind of thinking, okay, what is the exponent that you'd put on this 6 to get this 36? It's not a trick question. What exponent you put on 6? It would have to be 2. So this log is equal to 2. How about the log base 3 of 81? And it doesn't hurt to say it in your head so you kind of don't sound silly if you ever say it out loud. You would say the log base 3 of 81. Log base 3 of 81. You're looking for an exponent that you put on this 3 to get 81. So it has to be 3 to the, this one gets a little big, but you count all the way up to 4. It'd be 3 to the 4th. 3 to the 4th equals 81. Now, before we go any further, in math, we talk about functions. I know it's kind of a word the teacher uses, but you're familiar with a lot of functions. For example, you're familiar with the x squared function. If I tell you to do 7 squared, everybody knows that that's a number. That's 49. This is also a function. It's a function that makes you think, though, in a different way. It makes you think about an exponent. So what's a function? It's something that changes a value to get an output. So it takes this value and gives me an output. Just don't want you to kind of get lost that there's a word up here. Just because there's a word, it's still a function. It takes a input and it gives you an output. The output is just an exponent. Now, that's kind of like a level 1 logarithm. Like you just kind of think, what's the exponent? Let's go to what I'll sort of call a level 2. How about the ln of the square root of e? The ln of the square root of e. Now, that can throw people off. First of all, it's got a different ln. I'm sorry, it's got a different log. It's this thing called a natural log. But before you get worked up about that, the answer is still an exponent. The answer is still an exponent. So I actually want you to focus on this square root symbol. And I would rather see you first say, oh yeah, square roots. They're the same as exponents. Now, of course, they're the same as 1/2 exponents. But you got to get your brain to think exponent. Now, there is a base. There is a base. It's base e. We just don't write it. But that doesn't mean you can't think it. And it actually doesn't mean that you still can't lightly put it down, because this problem is really asking e, this yellow e, to what power equals e to the 1/2 power. So this yellow e to what power is e to the 1/2 power? Well, don't make it too tricky. It would have to be the same exponent. It would have to be 1/2. The problem is a little different because the exponent is already there. You just have to understand that the answer is that exponent. The answer is 1/2. Go ahead. It doesn't matter that I have e twice. It actually, no. Actually, I want to have e twice because that way I can say, wait a minute, if both these bases are e, then that means that the exponent has to be the same. You know, it's very much like if I stood here, Mason, and said, hey, 2 to what power equals 2 to the 10th power? Well, you know, the work's already been done for you. The 2's are the same, so of course it has to be the same exponent. But yeah, you don't change the exponent. Thankfully, you just use the exponent. Let's do another kind of level 2 problem. Honestly, level 2 just basically means we're going to have to do something besides just think of an exponent. We're going to have to do something. Now, this would be the log base 4 of 32. If you're kind of saying, am I supposed to know that exponent? Not like you memorized it, you know, back in 7th grade. But is there an exponent that I could put on 4 to get 32? Well, the answer you'll find out is yes. We might need, though, to do a little dance over here. Now, the little dance is to think about bases and exponents. Do you remember how we, for a certain problem a week or so ago, said that we could make the bases the same? The number 4, it's just true, can be written, the number 4, it's just true, it can be written as 2 squared. Now, it's kind of one of those things that you have to say, oh yeah, that's because 32 can also be written as 2, well, not 2 squared, but 2 to the 5th. Now, what's happening here is we're using a little trick. And the little trick is to realize that the bases can both be 2's. When you look at the number 4 and you look at number 32, you have to see base 2. Now, this allows us to then do a little bit of algebra. Those circled exponents are supposed to be multiplied. Once I multiply them, I can get 2x. And now, it's pretty easy to say something about my exponents, and that is that they have to be equal. So 2x has to equal 5, or if you're just ready to solve that, you can say 5 over 2. 5 halves. Make sure you don't lose in the shuffle what just happened here. We found an exponent because logarithms are exponents. We just had to find it. We had to find it doing a little dance. And the dance was to make the bases the same. One more kind of level 2 problem, meaning there's something additional that we need to think about. But once you realize what's going on with this problem, you'll say, well, that's pretty easy. The log of 100. Now, if you already wrote that down, or you're already looking at it saying, where's the base? Then you're catching on. There's always a base for a logarithm. Well, this is called the common log. If you want to write that in parentheses, you can. This is called the common log. What's the common log? Well, it's a log that always has a base. By chance, does anybody know? Well, it would be a base 10. Okay, now basically a base 10 is a common log to use in science, particularly chemistry and with scientific notation. But basically, a common log always has a base 10. So now I just got to think 10 to what power is 100? And of course, that has to be 10 squared. But remember where we came from. If you don't have a base, it's assumed to be the common log, or it's assumed to be base 10. Now, from what you've seen, I want to present to you these 4 problems. Mess around with them. Maybe you can get one of them right. Maybe you can get 2 of them, 3 of them. Maybe you can get all 4 of them. But I just kind of want you to think about what you've seen and see if you can apply that to any of these A, B, C, D problems here. Hopefully you've had a chance to think about the first one, but if you're stuck on it, 2 to what power is 32? 2 to what power is 32? Now, I'll share that if you have arrived at letter D but are somewhat stumped, that's a good thing. If you are stumped and are saying, geez, I'm not sure there's a way I can do letter D, just again help you relax, that right now is a good thing because there's something else I need to show you. Okay, but how did we do with 2 to what power equals 32? We want to make sure we're grabbing on to kind of like that level 1 problem. 2 to an exponent of 5. 5. Okay, there's really nothing else that you need to do there except know your exponents. 2 to the 5th power equals 32. How about letter B? Andrew, you did a nice job. Can I call on you to kind of give it in your own words? Indeed, you did. Would you mind kind of just sharing how it looked for this one? Okay. So the number 4 is the same as 2 squared. It's just true. If I give you one of these, you're going to be able to do this. You're going to be able to make them have the same base. But how do you finish? Good. I'll show this step right here, but that's exactly right, so that you can get 3/2. Okay, so if I give you one of these, you'll be able to do this. That is, you'll be able to make the base the same. Whoops. Well, the answer's up there. So why is it 0? B, in other words, any base to what power is equal to 1? Well, it's always a power of 0. This is kind of like a special logarithm, because if it's the log of 1, it's always going to be an exponent of 0. All right, well, I kind of gave that one away. Now, if you're looking at letter D and saying, but I can't make the base the same. Well, you're right. You can't make the base the same. There's not a base that 6 and 40 sort of share. And what we need is another idea. This is going to use your calculator. If you haven't pulled one out, I encourage you to do so. Again, I don't want you to just watch me. But we need something else. We need what's called the change of base formula. Now, the change of base formula, you can just copy it down for starters, but I want you to understand what it's saying. The change of base formula is saying that if I want to do the log base b of a, in other words, if I have some kind of base that I can't figure out, all you have to do is divide. This is basically telling you that if you have a base, like base 6, and I can't figure it out, all you got to do is divide the log of a with the log of b. Now, that would mean, like for this problem, that would mean that the log base 6 of 40 is going to be the same as the log of 40 divided by the log of 6. We just want to make sure we know how to do that on the calculator. Well, have you ever noticed that there's a log button? It's either in your exponent menu or it's on your keypad. But you can just do the log of 40 divided by the log of 6. By the way, why is it called the change of base formula? Like, why change the base? You see, the base was 6, for example, but now it's base 10 because you're using the common log. Just, by the way, when you use this button on your calculator, again, it's the common log. You don't have to worry about that too much. You just need to realize that that answer to 3 decimal places, we usually use 3 decimal places, is your logarithm. I guess if we're going to round it, it'd be 2059. Now, what I just showed you here, it's pretty simple, but it's also pretty powerful. And I want to make sure you realize that what you just found is an exponent. Ooh, kind of sounds a little bit like the beginning of the period. Wait a minute, 2059. Yeah, it really does work. It really does equal 40. Okay, obviously close to 40 because we rounded. But what if we did have that problem at the beginning of the period? What was that problem again? It was the, it was the 4 to the x equaling 20. Yeah, that's what it was, 4 to the x equaling 20. A lot of things are going to kind of come together here in just the last couple minutes. But first of all, this statement can be written as a log. It can be written as the log base 4 of 20. But the cool thing is that log base 4 of 20 can actually be solved by dividing. On your calculator, the log of 20 divided by the log of 4. I hope you're dividing it because, well, I'm not going to do it on the calculator. I'll have to pull the screen down, but did you divide it? And does the number look familiar? It's the exact same number that we found. Because a logarithm is an exponent. A logarithm is an exponent. So we now have the ability to solve this equation that a few minutes ago was kind of a new idea that we had to guess and check, but 3 to the x equals 30, you now have the ability to solve that because any exponent can be written as a log. Base, in this case, base 3. And it shouldn't take you too long to, every time you see one of these logs, to realize, wait a minute, I can divide that on my calculator. And if you divide it, you actually find that exponent. You actually find that exponent. What is this round to 3 decimals? I got 309. Okay. Usually we use 3 decimals just because it's a little more precise with the kinds of problems that we're doing. One more. But yes, it's going to use the letter E. It's going to use the letter E. I don't want the letter E to suddenly throw you for a big loop. In fact, most of the time when kids pick up on the letter E, they say it's actually easier. Why should it be easier? Because it's already a button on your calculator. But listen, it's a base E. Since it's a base E, I use a natural log. If you put the numbers where they should go, you would realize that, that it has to be the natural log of 40 that would equal x. Now that is a button on your calculator. Make sure that you find it. And it doesn't require any division. I can just do the ln of 40. Again, ln stands for natural log. So you get 3689. 3689. You kind of have to follow a little bit of the flow of today's lesson. We started with just understanding that logarithms are the same thing as exponents. And then you can use that to help find that exponent until you get to a problem that you can't do. And this division method helps us to actually find the x that was in that exponent. It kind of takes us back to where we started. Okay, take a look at the homework helper. I kind of laid it out the same way. I'm going to walk you through the same kind of problems.